Welcome back. In this series of videos, we're looking at how Access handles date-time values. We started by looking at how tables store date-time values. We looked at some of the display formatting options available to you to alter the way date-time value is presented to your users. We looked at table level formatting and formatting you can apply in forms, reports, and even in queries. We also looked at date functions. You can use date functions in logical evaluations to do things like highlight certain data points for further analysis. We looked at using other date logic to group date-related values for a summary report. We also looked at things like filtering and sorting, where you can use date ranges to filter the records returned into a report or a form. In today's video, we're going to use sample data taken from this report, which is the customer work completed after due date report. This report was created and featured in an earlier video to allow us to identify those cases where our recorded completion date for a project was later than the estimated due date we initially assigned to that project. Now, the idea here is that if a project is due on a certain day and completed within a certain time frame after that due date, it's probably not a problem, potentially a problem. We want to identify those projects which are substantially late, where the completed date was more than 30 days or more than 90 days after the original estimated due date, because that may mean a different kind of problem. But in order to get to that next stage of analysis, we have to have the report to show us that data so we can pick which projects to focus on. Let's start that by picking this start and end date range, because I know that this will give me a project I want to focus on. This is for work done, or excuse me, started between 5/26 and 5/27/2016. On the 26th, we started this project for this customer. Originally, we estimated that it would be done by July 31st. That was the due date. It was actually recorded as complete in the database on August the 8th, so it was roughly 8 days late. This falls into the range of late completions that I want to look at for a particular analysis. I want to know, is it late because of bad estimating? Did I really end up doing a lot of work after the due date, or is there some more administrative bookkeeping kind of issue there that prevented it from being recorded as complete on time? Now we have identified a project and a customer to focus on. Let's go back and look at the two reports that we the two forms we created for today's video. They're both managed customer work. However, one has a calculated field in a query. The other one has a calculated control on a form. This form depends on a calculated value, and we calculate that value each time we run the form. This one does it on the form in a control. This one does it in a query. Let's look at the query first. You may recognize this as a cascading combo box. This is a method for filtering a large number of records in the select work table by displaying only those work items that belong to this customer. This technique is called cascading combo boxes. I will come back in a future video and explain how I go about doing cascading combo boxes. You can probably find other resources that'll help you understand how that works. This is the work, and as we saw from the report, it was started on the 26th of May. We originally thought we were going to be done on or before July 31st. We came back and recorded it was completed on August 8th. So now we have this late completion, and we're going to try to figure out what might account for that by looking at this subform. And in this subform, we have all of the work details that go with this project. And scrolling down to the bottom, we see August 8th worked a quarter of an hour. I happen to know that I bill in quarter-hour increments. So this is probably not exactly 15 minutes. It could be anywhere from 1 minute to 20 minutes. But my software is set up that it bills, or it records time in 15-minute increments. So it looks like what happened here is the bulk of the work was actually completed pretty much as anticipated just before the end of July. But then 8 days later, I had to come back and do some small task. One of two possibilities. It was a bug that was reported after the project was put into use, or it could have been some slight modification that the client said, I wanted to do this instead of that. In any case, it took 15 minutes approximately, or maybe even less, to do that. So even though this was recorded as being late, I don't consider this to be a significant issue, or excuse me, a significant indication of a processing problem. Now, in this same form, I have a different function, different business rule. And we can sort of use this as a stepping off point to expand our review of business rules and the date logic required to enforce them. In this case, what we're looking at is the accounting rule that says, create invoices within 14 days of the date the work was completed, but not before. So, the work was recorded as complete on August 8th. This is the calculated value. It's actually a calculated field in a query. So the query which provides records to this form does the calculation in the query. 8 and 14 is 22. Notice what happens if I start changing. It recalculates the create invoice by date. And it happens on the fly. It happens only in this query behind this form. Put this back the way it was. Let's close this form. Open the calculated control version. Exactly the same. Except this time the calculation is being done directly here in this control on this form. We see the same instantaneous updating as it recalculates this value. Why did we do it this way? Why didn't we hard code the invoice date, the create invoice by date, in the table? Well, there are a couple of reasons. One is from a design principle. We do not store calculated values in tables under most normal circumstances. Now, I am aware there are cases where people do decide to store a calculation for some reason or another. Now, that's typically going to do with performance, where calculating a large number of values on the fly may slow things down, and you may want to just store that calculation and have it available more efficiently. If that's the case, you'll know it, and it will be a special case and handled as an exception rather than a common design approach. I applied a bit of logic, formatting logic, to this control for a different purpose. So let's see what happens if we change this to today's date. Now you see when it updates the create invoice by date, it also, the form, this is happening in the form, conditional formatting, also updates to show that in red with a white font. The reason for that is we want to emphasize or to call out those invoices or those projects where the completion date compared to today's date puts it within our 14 days. We want to use this as a flag to users to say, okay, here's an invoice that needs attention. You may need to create an invoice for it. Now, I don't have the invoice hooked up here. This is a placeholder only, but in a fully developed database, that may be the next step. It may actually open a form where you would create the invoice. I'm going to make one more change to show a slightly different conditional formatting. Now this time we applied slightly different conditional formatting based on this value compared to this value. Today is the 12th. My assumption is that you cannot mark work complete at some date in the future. You don't know whether it will be complete tomorrow or not. If you do that, then you need some flag that tells you this is an unusual or different situation. Pay attention. And we use the green, light green background with the red font to indicate that. And if we go back to our original work complete, oops, that was 16. Go back to our original work complete date. Now you see that it grays it out. We've got a light gray font on a dark gray font on a light gray background. And those are for older projects where I'm pretty sure the invoice was done, although there's no guarantee from just this little mechanism that that's the case. So that's how the display formatting works. Let's quickly look now I'll get this back up. And let's look at the query, which provides the records for that form. The invoice due date is the field which is bound to that form, to that control on that form. And it's a very simple calculation. We're going to add 14 days to the complete date, and that'll be our invoice due date. That will be calculated dynamically each time the complete date changes. And if I change it here, it will change here. And again, we're doing that so we don't have to run the risk, of getting out of sync between the calculated value and the actual currently applicable value. If this date changes, this changes automatically. That's how we do it for the calculated field and the calculated control on the form. There it is right there. Exactly the same formula. The date function, add 14 days to the complete date. In this case, since it's a control on a form, we use the equal sign to indicate that it's a calculated value. So between those two, we have two different ways to show calculated values on a form. Of the two, my experience has been that in a case where you have a single control like that one, where there's just one value being calculated on the fly, is just as efficient to do it either way. In cases where there are many records, say in a subdata sheet, in a subform in data sheet view or continuous view, and that calculation is being done many times, you may find that the query version provides better performance. But the only way to know for sure what's going to happen in your case is to try both out and see which produces better results. I tend to go with the query version primarily because I think it is usually going to give me better performance. With that, we've covered one more aspect of date time handling in Access. If you like what you've seen so far, please hit the subscribe button. Come back and visit us when we have our next video up. Thank you.